Topic is fitting the line to data. Another name for this is called, put this at the top, line of best fit. Okay, FIT. So line of best fit is the topic for today. Here it says sketch an example of each type of correlation, and you guys may have done scatter plots before. How many of you remember doing scatter plots? So scatter plots, you just don't connect. They're kind of just scattered, and they have dots like these, and you don't connect them. So if we have a scatter plot that looks like this, where the dots are going in, let's say, let's change that to positive direction, then it would look something like that. Okay, so they're just kind of scattered, and you want to make that on your little coordinate plane as well. So we call that a positive correlation because the dots are going in a positive direction. And this line that we would cut across the middle, okay, technically that would be called your line of best fit. So since we can't connect all of these lines and come up with various different equations, we just basically take the center of the data and try to draw a line in that center and come up with the best possible line that would fit this data. So that's why we call it line of best fit. Okay. Negative correlation, of course, it looks just like a negative slope. So the dots are going in this direction. And again, we would just take the center of the data, try to draw that line of best fit to come up with an appropriate equation. And the good thing about it, your calculator can give you that equation. So we're not even going to try to do it all mathematically. We're going to just let the calculator tell us what the line of best fit for the data is. Now, no correlation at all just simply means you might see dots anywhere. Okay. And there's no correlation because it doesn't look like there's a positive slope, a negative slope. They're just kind of scattered everywhere. Okay. So which one of these data sets do you think would fit this particular situation? It says the two graphs show the gallons of gas that remain in the gas tank and the miles driven for each of the 6 hours. Which one do you think would be the appropriate graph to represent traveling for 6 hours, and then what is happening to the gas as you are traveling for that amount of time? So we're going to call this graph 1 and graph 2. All right, what do you think? Yes.
Graph 1.
Okay. He said graph 1. What do you guys think? Okay, so when we start off with 0 hours, okay, the gas is up here, correct? And then as we continue to travel for 1 hour, you can see that it's going down. What's happening in this graph? As you travel, it looks like the gas is what? Right, like the tank is filling up, which we know that is not the case. Okay, so obviously here would be the correct graph, right? Now, what we're going to do, because the whole purpose of getting what that line of best fit is, so you can make predictions. So once you have the line of best fit, then you're able to make a good prediction based on some facts. So let's see. These are the steps we're going to take on the graphing calculator to get the line of best fit. So if you go to your graphing calculator, there's a button that we're going to be using that's called Stat. It's right here. Okay, so in a few minutes, I'm going to ask you to hit that, and then I'm going to tell you what to do from there. All right. So let's take a look first. It says calculate the line of best fit for the length of a tadpole. So here are the days for the tadpole, like 5 days, 2 days, and then over here it tells you in millimeters how the length of the tadpole based on the days. Okay. So what we're going to do is, after we get the line of best fit, the equation, because this would actually be as like a scatter plot. So after we get the equation from the calculator, then we're going to approximate what is the approximate length of a tadpole that will be 11 days old. Okay, so this is like your X column and this is your Y. So if they're giving us days old would be in the what column? The X column. So once we get that Y equals MX plus B equation from the calculator, the days then 11 will be replaced with the X variable. Okay? All right, so are we ready? All right, so on your calculator, you're going to hit stat, and then you're going to hit enter. Now, when you hit stat and enter, you should have something at the top that says like L1, L2, and so on. Okay. Now, if you have numbers there, does anybody have numbers? Okay, I'm going to put some numbers so you can see what you should do if you have numbers. Let me just put in some numbers just so you should not, but I want you to see what you would do if you did. So if you have numbers in any of these columns, you would simply take the cursor, you would put it directly on the top bar where it says list 1, list 2, or whatever, and then you would hit clear. Nothing's going to happen until you cursor it back down, and then it'll clear the entire list. So that is how you clear it. So what you would do is put your cursor on top of it, the column, you would hit clear, and then you would bring it down. When you bring it down, it will clear the entire list. All right. Okay, so here we go. We're going to put in the numbers for the ages in the same order that they're in on your worksheet. So on page 22, it starts with 5. So we're going to hit 5 and enter. So every time you put in a number, you just hit enter. 2, enter. 9, enter. 7, enter. 12, enter. 10, enter. 3, enter. And 6, enter. Okay, then we're going to cursor, just arrow over to the next column so we can put in the length of the tail of the tadpole. So 14, enter. 15, enter. 3, enter. 8, enter. 1, enter. 3, enter. 12, enter. And 9, enter. All right, so once you have everything in, okay, you got your numbers in, you're going to go back to stat. Everybody hit stat again. Okay, once you have your numbers in, you hit stat, and then watch this, you're going to arrow over to calc at the top. So just arrow over once, and we're looking for this right here. So this is option number 4. See how it looks like MX plus B? Okay, it's called linear regression on your calculator. So that is that, your calculator doesn't say MX plus B, it calls the slope A. So that's the one we want. So we just simply press 4. Okay, now when you press 4, you should see something like this. How many people see this? Like your X's are in your L1, your Y's are in your L2, and so on. Okay, so if you have an older version calculator, you might have to just hit enter. We're going to hit enter about 4 or 5 times, and then this will pop up. Okay, so just keep hitting enter until you see something like a whole bunch of numbers where they give you the slope and the y-intercept. How many people got this answer? All right, great. All right, so obviously we're going to round this. This is our slope number, negative 1.482. So we'll go out 3 spaces because the more you go out, obviously, the better your prediction will be. Okay, so negative, can somebody write that down? Because when I go to my other slide, I'll need to write it down. So write down y equals negative 1.482x plus 18.129. Okay, so if someone can write that down for me. y equals negative 1.482x plus 18.129. All right, so we just transfer that back over to here. All right, so now it says we want to make an approximation for the length of the tadpole when it's 11 days old. Now, this is the tail of the tadpole, of course, when it's 11 days old. So all you would have to do is go back to your calculator, hit your y equals key. Okay, so everybody hit y equals. Okay, once you hit your y equals key, if you would go ahead and type this in. Okay, everybody type this into their y equals. I'm not going to show this part. Okay, just hit your y equals and type in this equation. Okay, then you're going to go to the table on your calculator. And you're going to go to 11 and see what that number is in the table. So put in your equation first into the y equals. Go where you have 11 in the table. And then I want someone to tell me what the y value is. Okay? All right, so it looks like you should have 1.827 when x equals to 11. And again, if you got to type in the entire equation, don't forget to put in the x. Okay, that x is important. So make sure you have negative 1.482x plus 18.129. All right. Okay, let's move on to the next page. So it says calculate the line of best fit with it. Okay, number 2 says calculate the line of best fit for winning times. So here we are. It says the winning Olympic times for women's 100-meter run from 1948 to 1990 are shown in the table. So what they have here is they're telling you that year 1948 is going to be like year 1. So let's actually change these numbers to like 1, 2, 3, and so on. All right, so basically there should be 13 different years, okay, because they want you to coordinate the first year as 1, 1952 would be 2, 3, 4, and so on. So we're not going to be putting in the actual year number. You're going to be putting in these numbers here. So again, this is X, this is Y. Okay, so technically you have your L1 column and your L2 column. Now, but look, they want us to, and I'm going to change this right here. Instead of approximate at 1981, let's approximate at 1998. Okay, so we're going to change that to 1998. Okay. All right, so we're going to go to our calculators and we're going to hit stat and enter. So hit stat and enter. So now we have list here. So let me first clear out my history. So what I'm going to do is just put the cursor directly on, and it doesn't matter if you start with list L1 or L2 first, it doesn't matter. I'm going to put it directly on it. Okay, it keeps moving. It's going too fast. All right, then I'm going to hit clear. Then I'm going to bring it down. Do the same thing to L2. Put it directly on it, hit clear, and then bring it down. Okay. So now we're ready to put in 1 through 13. So if everybody would go ahead and put in 1 through 13. For L1. Okay, I'm just going to do that, and you can do it on your own. And you don't have to wait for me to do L2. Just go ahead and put in your data for L2. All right, I just finished putting in 1 through 13. Now I'm going to cursor over to L2, and I'm going to put in those numbers. Okay, so once you have in your L2, then we're going to go back to stat. So once you finish your data, you go back to stat, go over to calc, because you want the calculator to calculate something for you, and then option number 4, and then you just keep hitting enter until you see the slope and y-intercept. Okay, so did everybody get like a negative 0.0769? All right, for the slope and 11.677. Okay, if someone would write that down for me so we can transfer it to our note sheet. So negative 0.0769x plus 11.677 equals. So once you have it written down, hit your y equals key. You're going to type in that equation right here. You're going to go to the table. Now, since I'm asking you to approximate at 1998, 1998 was going to be, what, 15 in your table? Actually, it may not, because we're going by what here? The table, since this table is actually incrementing by 4s, let's add 4 to 1996. So that's going to give us year what? 2000. So that'll be a lot simpler to do. Okay, so let's change this to 2000. So that's going to be 14 in the table. All right, there should be 14. Okay. All right, so we're going to have negative 0.0769. I left out the 7x plus 11.677. All right, and then we're going to do year 2000. Okay, so that's just going to be 14 in your table. Anybody have the answer? Yes. 10.6. All right, so we should have 10.6. Okay, that would be a good approximation. Okay, so again, these are to give you good predictions. So once you have this equation, you're able to make a better prediction. Because if you actually would graph this, it will come out to a scatter plot. Now, would this scatter plot, just going back to page 19, would this scatter plot be a positive correlation or negative correlation? We'll look at the slope number. Is the slope negative or positive in our line of best fit equation? Negative, right. So it would be a negative correlation. Okay. All right. Now, what you're going to do is do this one here. And this one did not ask you for a prediction. It's just asking you, again, this is your X. This is your Y. This one is only asking you what will the equation you get on the calculator. So you're going to type it in, just like we just did. So this is what you're doing on your own, as well as question 4. Type in your L1 and L2 and pick out the correct equation from the calculator. Okay. Now notice they didn't put it all in slope-intercept form. So like in F, this really should be like 10x minus 3. So pay attention to which number is the slope and which number is the y-intercept. Okay, so I'm going to let you finish that up.